Good afternoon, sports fans. Yeah, I know. Whatever. Let me move closer to get away from those lights. Since I'm into this Kohler, it's a K301 10 horse, as I said before. I figured I'd go through some of the stuff to look for when you're tearing these things apart. All right? Now, where do I start? One of them is take a look at your lifters. I'm just going to pick stuff at random, but I'll stay with the valve train as much as I can. You want to look here, all right? You see that divot? You want to see how deep it is. It's set for the valve. Well, you need to round it to flatten it back off. In fact, quite often these things have a little round surface to them. But if it's nice and flat, that's even better. How do you fix it? Well, it's difficult. I happen to have a valve grinder, two of them, in fact, but one in particular that I can set this on, and it's designed to clean this. Because it's not perfect, it's an antique. I mean, like as old as I am, 60 something years old, that I put it on there and you turn it. When you turn it, it has a beautiful little crown to it. And then you've got a surface that your valve tip can hit. Is it going to make that big a difference? In general, no, because these things rotate, and the intake and exhaust valves on the ends here are identical. What's the other one? Here. You're looking for a cup surface. Just put it on, put something flat across it, hold it up and see if you see daylight under it. If it's bad enough, you know what you can do to this one? The same thing you can do to this end if you're very careful. Make sure you have a perfectly flat surface and approximately between 180 and 220 grit, because these things are relatively hard, and do a figure 8, 4 or 5 times, turn it. Keep doing the figure 8, turn it, keep doing the figure 8, turn it, reverse the figure 8, that kind of thing. Random. Then get it back down so it's relatively flat and relatively fine. Don't worry about a shiny surface. At 320, if you really want to get particular, get it down to 320, maybe a little 400. But to have just a dull finish is perfect. They found out years ago that the dull finish holds oil. So you're going to be okay. And you're only taking off like hundredths of a thousandths or tenths of a thousandths. I mean, you're doing it by hand. There's not much. And some of you are going to say, well, I could do that with a file and a piece of paper. Maybe. But to be honest, I'd have somebody fine machine a block of steel. Yeah, just a nice big old, half inch, 3/4, 1 inch, whatever, block of steel. Have them machine it off. That would be the better way to go. Some of you are going to say, well, I can, whatever. Just make sure you're flat. You can do the same thing with the valve tips here, but like I said, I've got two. One is a valve machine tool, which I just did here with New Way. And you take out the valve and you can put in the disc, put this on the unit, put it against the disc, and I can flatten that sucker. It even has a 45 to put that chamfer back on. Is that chamfer critical? No, it isn't, but it's helpful because it helps center things. And yeah, you're doing it manually, but it takes that sharp edge off of there. If you have a lot of sharp edges, they tend to be stress areas and cause cracks. And they can chip off, so that's one of the reasons that chamfer is there. The valve, of course, you're going to clean that thing up. You're looking at the face. Now, this face has been machined. It was easy enough to machine, but you see that edge there? That's not a sharp edge. It's a flat edge. We're talking, 32nd of an inch or so? On a small engine, that's a good, what they call margin. You need the margin, a place where the heat can go. And if it's a sharp edge, then the sharp edge doesn't have enough metal to absorb the heat. And in the airstream, it'll cool it down if there's enough material there. But that knife edge, that'll just get hot and melt. You need, on larger engines and such, a 32nd of an inch in the cars, it's passable. On hard-working trucks and tractors, no, you want more than that. But the 32nd of an inch can work if you're not out there plowing and chopping all day long. But on a Kohler that's in nice shape like that, that's a beautiful thing. What else are we looking for in the Kohler? That's already been refaced because it had a divot. See if I can hold it there long enough it can focus. There you go. that divot, and there you go, you can see it quite deep. I know it's off to the side of the screen, but you can see how deep it is. Now if you keep going, look there, it's a flat spot with no divot, meaning this is so overheated that it's out of round. And with that divot that deep, and look at that margin, the margin is already just barely a few thousandths over 32nd of an inch. This valve shot for two reasons. One of them is most likely it's the original valve, but not necessarily. If it's not an original valve, it might be possible to machine it, but you need to know the original Kohler valves in the K series were stellite faced. You heard me, faced. And everyone had ever seen, if you actually work the engine to any extent, it wouldn't take the heat. It would melt the thing down and put in a huge groove deeper than this. And it'd burn right through the valve. I saw it dozens of times because I worked at a shop where they kept grinding the valves, and they'd grind it again and grind it again, put it back in. The next year it'd be in the same condition. Bad. So exhaust valves are always a replace, and you say, well, then replace them both. You're right. Well, why'd you face the other one? Because I wanted to see how it would turn out. That's all. This, machining it and seeing what's left for a margin, gives me an idea how bad the heat was in this engine. And this exhaust valve tells much of the story, but so does the intake. That means the seat for that intake is most likely hasn't moved because of the severe heat. The exhaust seat, that's probably going to be a problem, something to look at. How do I know? Because that was beaten in with a groove, but salvageable. And it's a shiny seat, beautiful seat. Still, I haven't touched it. But this one, we already know that there's a spot in the valve that's flat with no groove, which means it's no longer concentric. And that might be the valve, that might be the seat area. It got so hot in different areas, the seat itself can move from heating and cooling cycles. Severe heating and cooling. Not just normal heating and cooling. Obviously, problem. If the valve doesn't rotate, which in this case they really don't rotate much if they do at all, the idea is a different part of the valve will hit the seat at a different point. But that seat with severe heating, because metal is thicker and thinner, etc., air blows by one side more than another, and it can actually go out of round. So, and the other part is if the casting got hot enough, long enough, then you start losing the press fit for the seat in that cast iron block. So it's something else that I'll probably have to just lightly peen the seat in before I reseat it. But now you have an idea of what to look for on these guys. What's the other? Springs. Now this one, you can already see on this one. They have two springs here. And let me see if I can tilt this and you can see them. Yeah, that's not going to work. Alright. Tilt you down here? Nope, can't see it. Well, I don't know if you can see it from here. Let me see if I can get it. Oh, this is fun. There they are. This one over here you can see is at an angle. That's a bad spring already. Is it serviceable? Yes, it's serviceable. But that's one of the things you're looking for with a spring. The other one is, are they roughly the same height? And in this case, as you saw, they're about the same height. The other one, too, is here at the top. See those springs up there? Now, if I move them slightly, you'll be able to see that the coils up here are closer together than down here. This is what's supposed to go up on the engine against the casting closest to the combustion chamber. Well, these weren't that way, which gives me an idea that maybe they got too hot. But they feel pretty doggone tight. I do have a spring tester over there, and they are going to get tested before they go in. I don't even know what the specs are for it. Never had to look them up before. In this case, well, yeah, we're looking them up. Okay, so we've gotten into springs. We've gotten into the lifter. What else? Oh, yeah, we got into the valves. They're out of the way. What else do we have? The governor shaft. Well, you got to gut the engine to get the governor shaft out. Cam, everything out. In fact, the governor has to be out to get the shaft out. What are you looking for? Well, you're just looking for wear on the shaft anywhere. These don't have a seal on them, and that little brass nut that's in there, sometimes you have to replace it and the shaft to prevent oil from coming out that shaft. There's two reasons it comes out. One is there's no seal. The other one is blow-by. It's a handy place to come out when there's a lot of pressure in the cylinder or in the crankcase, and it can't come out through the breather as fast as it needs to. One of the biggest things here is that little locating snap ring there, shaft wear, and is this tight. That little flapper there is known to get loose, and that'll screw things up. It doesn't move much because the thing's in a groove. All right, it's locked in there pretty good, but still, that rivet loosens up and makes a mess on some engines. Big mess. So those are things to look for in the shaft. Now, when you're taking this thing apart, the arm on the outside, sand that tip off. I had to do that to even get that up. Think of getting that arm off of there. You say, well, just put something in there and split the... I did. Screwdriver. They don't just come off. You got to clean things up. Another one in your breather. You've got your little reed. You're looking here where those circles are. You're looking to see if there's ridges. If there's ridges, it's junk. The other one is it bent? This one's a good one. It's not bent. Here, look at that. You can almost lose sight of it. So this one's pretty good. That's what you're looking at. The other one is in the center. That's where that rubber dinger is to hold it in place. And over here, where it sits against the housing in there, you're just looking to be sure that things aren't worn. Shiny is fine. You start feeling little imperfections, it's junk. That's important because oil can just go blowing out in the ground. Governor again. You're looking for gear wear. You're looking to be sure all the teeth are there. This is a cast iron jobby. A lot of them are nylon. Now there's a brass washer that goes here. Be sure you have it. You're looking for the weights and the pin. Make sure that they operate freely, both of them. And with the weights in particular, you're looking to see side play is fine. That's normal. You're looking for wobble. When they're sitting here, you're looking for up and down wobble. This one is, it's okay. It's serviceable. But the cast iron holds up much better than the nylon. Still, the nylon, there's nothing wrong with it at all. But you are looking to, I've seen a few of these where the gear teeth got knocked off when an engine blew a rod like this one did. You're going to get up in the gears and mess them up. So you need to look at that very carefully. The other one, you're looking at your retainers when you're taking it apart. This is the spring cap on top where it goes up against the block so that you're not wearing into the cast, and the spring isn't wearing a groove in the cast, and the cast isn't wearing out the spring. And it also helps in heat transfer. Just keeps the spring centered because this sits around the guide and it holds the outer edge of the spring in place. Same thing with this one. Check your locks. I didn't pull any of the little bitty locks out, but you want to make sure your locks aren't bent, chipped, turned, or anything else, because sometimes people do stupid stuff. As long as we're on cams and governors and such, you're looking for wear. This cam is in excellent condition. Sometimes what you'll see is a circle pattern up here, and that usually means it's starting to wear through the hard surface. But the circle pattern also was there because it's turned the lifter so many times that they start developing a circle pattern, just like you saw when I showed you the lifter had the little circles in it. Same thing here. You can go back here and look at that. The other one, look at your cam here. Believe it or not, this is your fuel pump cam. This one isn't being used, so there's no grooves in it, but that's what you're looking for. A groove in that, the circles and wear in here, burrs on the edges, there's none there. On these, you're looking for wear on each end. Also, wear here on the little nose tip. This is where your push rod for your points goes. You're looking for heavy wear there, or wide where this thing's dancing back and forth. And last but not least, your compression release is here. And make sure that that puppy moves freely. Usually what happens is one of these is a lock mechanism for the other. Just make sure that they actually do move as they're supposed to. Now that, okay. This is where the little tab is. And what does that do? Well, when it's under low speed like it is now, that's raised up. And it just touches that lifter, which means your lash is important. You're coming up on compression and this thing just gives it a bump. coming up on compression, just to hold the valve open until right before, like an eighth of an inch before top dead center, a quarter of an inch, and then it closes the valve again. So it only has a little bit of compression for cranking. Well, once you get it cranking that way, it'll get up to 150, 250 RPM, somewhere in there, and then this bottom weight drops out, and the little bugger moves out of the way, drops down. And then once it's running at that speed, even while you're cranking, because of the flywheel, it'll have full compression when you fire up and run. Now, some of them don't. You turn slow. You only get about 60 pounds of compression, some as low as 50, some lower because of the valve lash being too tight. But you're looking for about 60, 70 psi when that thing's running, or spinning. Then once it fires, it gives it a shot, and this thing opens up and goes to full bore. That's why you hear ka-dunk, ka-dunk, pop, bang, and it's running. No, this is part of the reason. You have to be sure that little hairspring is in place. Don't damage it. You can replace the hairspring, and that's about it. Anything after that, you got to replace the whole dang cam. So, and also these are weighted. This one's weighted so that when this section releases, that weight will fly out and take the tab down. All right, so shaft, you're looking for shaft wear. Obviously, you're going to put that little devil in there and see how tight that is. Whoops, only goes in one way. One end's a little bigger than the other because it locks in the block. Now this goes in there tight. And all dirty oil's been in there. That's the other part of the problem. But this is nice and tight. The shaft, being that it's pressure driven in the block, you put it in from the flywheel side and it slides right through the hole through the cam, and then it press fits into the other end of the block. The outer external end, you can actually see this end. And you just drive it in until this end is flush with the face of the block. And then the gaskets and the aluminum end cover hold it in place. Alright, so we killed the cam. That's pretty well. What do we got left? Not much. Ah, there we go. One more. This stuff's going to have soak in the carburetor cleaner. Last but not least here, at least for today, is the main bearings. I believe they're both identical. So what are you looking for here? One of the things, and this one's excellent, both of them were snug fit in the casting, but you can still drive them out easily. Well, this says international on it. Made in USA. Oh, ST436, I think. Yeah, ST436. Made in USA. Original bearing. What are you looking for? On the outside, you see how this is smooth and shiny, no lines? Yeah, if you see lines in it, that means it's been spinning. Same thing on the inside. However, on the inside, quite often, you will see, I don't know if you can see it here, but there are some light lines on the, yep, there you go. You can see them on the inside, which means the crank has been turning a little bit. That's pretty common. Now, the other one you're looking at is your cage here. Make sure the cage is all together, riveted, one piece. This one actually is spot welded. You can take a look at your welds. And you're going to grab the outer edge here and the inner here. And you're going to try and wiggle them back and forth. A lot of these are very loose. This one isn't. This one is excellent. I mean excellent. There's two of them in there, one on the input, one the other on the output. So that gives you an idea what you're looking for internally other than everything else. Now the crank I have in there, I already showed you before, the crank has aluminum on it, so it's kind of a waste of time to even show you. But you're looking for the same thing on the journals there. Do you see a lot of lines on there? Is it shiny? Gives you that too shiny. That means if you see glass smooth and little lines around there, it means it's been spinning a lot. You have to check your fit. It's supposed to be a very just a slip fit is all the bearing is on the crank, and it's a very snug light hammer fit in the housing, the block, and in the front housing, the aluminum. Hopefully that helps some if you're working on these things. Remember the flywheels on there. I showed you the T-bar puller I used before. It's a slotted one. The things are cheap. Don't screw around with pry bars and hammer. You need 5/16 thread. Get a rethreader, not a tap. Get a rethreader. If you get a tap and you run it through wrong, there's two things about taps. One of them is you're going to dull a nice tap. Okay? And a tap is designed to cut. So every time you run that through there, it's too much of a possibility that if you're not perfectly centered, you start cutting threads. You say, how many times am I doing that? Doesn't matter. A, you ruin the tap. B, you can ruin the hole. And if it's a bad enough hole, you'll snap that puppy off and wish you had a rethreader. Sure, rethreader's hard, but not as hard as a tap. So you clean your holes out, PB Blaster, WD-40, whatever. Clean your holes out and run your rethreader in and out. Put that T-bar puller on there and just give her a few turns. Tighten it. Mine, I used a little 100 foot-pound impact. No, actually it was a 200 foot-pounder. Infinium by Matco. Nice. As long as you don't look at the price. If you're a little guy like me, I was running professionally, working for another company. I bought the Matco stuff. It's equivalent to Snap-on and Mac easily. In fact, the Matco guy was so cocky, he says, use it. He says, the more they use them, the happier the people are, and the longer the tool lives. I said, what? He says, yeah, the longer the Infinium tool lives, the more you use it. Not abuse, but he says, use it normal, it'll last longer. He says, I don't know, but that's what they told me, and he says, that's what I've seen. So Infinium is way ahead of the others. Snap-on has some parts about the way they build them that is better, a lot smaller. Their performance for the size is insane. Matco is a crazy price. Snap-on's is multiplicatively, psychotically insane pricing, but it's got it. So it's only about 55 foot-pounds that nut's on there, but it's a shallow taper, so that flywheel's on there pretty good. Get the puller, give it a few hits with a little light impact, 150, 200 foot-pounds. You can turn it by hand, but then you got to hold the fins on the flywheel. Just give it a few wraps. This one popped right loose. And like you saw here, there's almost no wear anywhere. Oh yeah, and the cam. I didn't say look at the gear teeth on the cam. Especially when you got something that blows up. Something gets in the gears. Look all your gear teeth over. Looking at your governor, however, tells you what's happening with the cam because it spins it. Like, I don't know what, 8, 9, 10 times the diameter is like this and this. It's really whirling there. It's probably 4 times or more. So you look at the governor, you're going to know what your cam gear is. So, and your crank gear and all of that. So anyway, that's just a rough idea what to look for on these things. And again, when you're putting it together, might I recommend your initial setup, use conventional oil your first few hours of the engine. Well, I'm going to get a break-in oil. No, okay, whatever, but these are all parts that have run together. You've made some changes, but nothing drastic. The idea is run conventional oils because they have break-in salts that are added into them that are supposed to help smooth out rough surfaces in the older engines anyway. And that's why a lot of newer cars have synthetics. They put together the engine tight, smooth, all designed for synthetic oils. So when you put conventional oils in there, that's why you put our car in there, my car in particular, Taurus X will say 3.5 engine, and it'll tell you that you don't put this oil in that engine, and that's one of the reasons why. The original, at this point, it's probably not that big a deal. But it does make a deal if you're 5,000 mile oil change, or 7,000, whatever it happens to be, and you say, well, I do it at 3. Well, then you could probably get away with a conventional oil. But it's not good because synthetics don't have that additive in there. So why put a conventional oil in there and possibly wreck your engine? On this one, you put the conventional in to break it in because it's old school. And then once it's broken in and running pretty good, your first oil change, which hopefully is going to be 5 hours or less, just a good running time, run around the lawn, come back, drain your oil. And you can either put conventional in and do another 10-hour oil change, which I would recommend, and then go back to your 25-hour or 50-hour oil changes, whatever the actual Kohler is. A lot of these older engines are 20 or 25 hours. They don't have a filter on them and they're splash lube. Old school. So what do? You change your oil a lot. That's your filter. Carrying the crap out with the oil, and that's one of the recommendations in the old engines, where they tell you fire up the engine, run it, warm it up to get the oil out, because it helps carry the sedimentary stuff in the pan out of there. It's been sloshed and moved around. Is it that big a deal? I don't know that it makes that much of a difference. With the newer engines, I wouldn't get too excited about it. If that filter can't handle it, and on your newer small engine stuff that has a filter, it's already clean, so it's a good idea, but there's a lot of stuff that you just sit back and think, dude, really? So it's up to you how you want to do that. How do I do it? Well, usually to get it in here, I've run the engine to warm it up anyway just to get it in here. So, yeah, I do it quite a bit. And air-cooled engines, they warm up fast, except in the middle of winter. And make sure of your viscosity. In this case, this Kohler is probably going to be seeing the 15W40 is what I think he runs in all of his. And it's obvious in there the problem wasn't with the oil. The problem was with the heat. And it did break down the oil. That was nasty looking stuff. But it was full. Air-cooled engines run hard and hot. And that's why do they recommend straight oils? One reason and one reason only. 1540 has the same protective lubrication properties under normal circumstances, if not more, because of the variance in the viscosity to follow the temperature range, than the 30. They recommend SAE 30 because these cast iron engines are abusive on oils, and that was old school oil. Low ash, well, it's all low ash now, even the diesel. And the idea was that it is abusive. If you have a 15W40 oil or a 10W30, your 10W30, the 10W, 10 winter, not 10 weight, 10 winter grade, is what the base oil is. And then it has viscosity improvers from there to get it up to 30 as it heats up. They make it flow a little thicker. Yeah, it's a base 10W oil. That's why some guys get all excited about it. That's a 10W oil and it works like a 30. Yeah, but that's the only difference is the viscosity. If you have a 10W oil and an SAE 30 here, SAE 10W over here, and SAE 30 here, from the same company, they're the same single grade oils, just a viscosity difference, unless you buy a separate grade of oil. But the same base, the same additive packages. Now make it a multi-viscosity. That's going to be your main difference. Don't know what to tell you, but that's what it is. Now the other one isn't a single grade. Some of them actually have a higher detergent in the old stuff, and diesels anyway. They had a higher ash and higher sulfur content, which helped the oil and the engine with the extra diesel stuff getting past the piston rings and valve guides to take care of that and neutralize acids and such. Well, they can't do that anymore, but it doesn't have the ash and the sulfur in the fuel that the oil has to take care of in it. And you say, well, ash and sulfur.
5 o'clock.
Oops, I'm getting a call. I'm late. Yes, dear, thank you. So, that gives you an idea of some of it. I'm late. Got to get going for dinner. So, think about those things when you're going through it. And look at the ratings of a lot of different engines. And you're going to find out the small engines, the majority of them today are 10W30s. Even in the winter. So, here, yeah, I'd run 1540 in this old girl. Because you know he's going to abuse it. All right, you folks have a good day. This is Pops, signing out on Tuesday. January what? Let me check. Oh, no, I don't want to see that. January 14th, Tuesday. Year of our Lord, 2025.